Okay, so this is the notes page on interpreting graphs, part 1, and we will start with a couple of definitions. So the first definition, the blank of a function is the set of all inputs. Okay, so the domain of a function is the set of all inputs. So inputs, those are the x coordinates, or the independent variables. So the domain is the set of x coordinates. So if you have an ordered pair, all the x coordinates are in the domain. Alright, so the domain of the function may be stated explicitly. So for example, if this is function notation, f of x equals x squared, and the input is always going to be inside, and the answer, f of x, is the output. So this is another way of saying y equals, but we want to get over using y equals, and we want to get used to function notation. Okay, and so here I'm stating the domain explicitly. I'm telling you that the input values have to be between 0 and 5, and it's 0 is less than or equal to x. That means 0 is included, and x is less than or equal to 5. That means 5 is included because of these little equal signs. So the domain is the set of all real numbers x for which x is between 0 and 5 inclusive. And so we're going to use something called interval notation. So we're going to take out the x, and in this context we're saying that the domain is bracket 0, 5. And we use brackets instead of parentheses because we're including the 0 and the 5. If we're not including the number, then we use a parentheses. The range of a function is the set of all outputs associated with an input in the domain of the function. So again, the function notation is really important. This is my input, and whatever I put in for x, I can put 0, 0.1, 0.2, just anything in between 0 and 5, and when I square it, I'm going to get an output. Okay, and that output is the range. Okay, and we call the range the set of outputs or y coordinates or dependent variables, and the reason we call them dependent is because these y values, they depend on what you put in for x. So there's always two things going on: input, output, input, output. Okay, so now let's look at a graph. And so I have this graph here, and I use Desmos. So the first thing we have to understand is that these little gray spots, they're not holes. They're really colored in. It's just that if you were looking at this graph in Desmos, it would be colored, and it might be a different color here. But if you look really, really carefully, and I'll make it really big, there's a hole right there. It's not filled in. Okay, that's significant. You want to understand how to deal with the holes. Okay, so the first question, determine the domain of f of x shown in the graph. Okay, so domain is the set of x coordinates. So what you want to do is you want to look at the x-axis and see where the graph starts. And the graph starts right here at -5, -7. So the point -5, -7 means that -5 is in our domain. So we have a bracket, and then all of these points are x coordinates. They're made up of x coordinates and y coordinates. So the x coordinates from -5, and it keeps going and keeps going and keeps going until you get to x is 2. Now notice there's a hole there. So the domain would be all the numbers bracket from -5, which means you include -5 to 2 with the parentheses, which means you don't include the 2. But you can't put 1, because if you put 1, then you're missing 1.1, 1.2, 1.3. 1.9999999 is in this domain. So we have to put this 2, even though it's not included with parentheses, because we want to tell people what the boundary is. Okay, so for the range, those are the y coordinates. And when you're looking at a graph, you're going to look at the y-axis and try to find the lowest y first. Okay, so this is my y-axis, and it has the negative numbers down here and the positive numbers up there. So if you just look at the lowest point of the graph, you can see that it's this point -5, -7. So the lowest y coordinate is -7, and that point is colored in, so -7 is included. And then you want to go up, and you might see that there's 2 points here, but it doesn't matter. There's not one there. So what we have to do is we have to understand that this point 0, 0 is in the graph, and this point -4, 0 is in the graph, and this point 2, 0 is not. But if 0 is in the range, and it is here and here, then 0 is in my range. So I don't get confused that there's a hole there. I'm just going to keep going. Everything is defined. All these y coordinates are defined. Even at 0 it's defined. And go all the way up, and the highest y coordinate I see here is 3.38, and that is a point, so 3.38 is in my range. Okay, so don't let that confuse you. That point is not in the graph, but 0 is part of the y coordinate here, so it's in the range. So there's no reflection of that hole in this range. You don't have to account for it. You counted for it here when you said 2 was the boundary with the parentheses. Okay, number 2, determine the domain of the function of f of x shown in the graph. Okay, so another convention thing. These are made by Desmos, these graphs. So Desmos does not put arrows at the end. So if you see this in the lab manual, just know that unless there's a really definitive dot, these graphs go on forever and ever. And again, these are not holes. You'll see a real definitive hole. These are points that are just a little bit lighter colored. Okay, so I'll color them in. So don't worry about those. Alright, so again, the domain is the set of x coordinates. So I'm going to look at this graph, and this graph is going to keep going up and up and up and up forever and ever. That's easy to see, but not only that, it's also going to keep going to the left forever and ever and ever and ever. So that means that the domain is going to be from -infinity, and then over here it's going to keep going up, 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 but that's not the domain. It's going to keep going right forever and ever. Alright, so this domain is -infinity to infinity, and the -infinity to infinity never has brackets because we can't contain -infinity. This is an open boundary, just like this 2 was an open boundary. So always use parentheses. Okay, so the range, remember that's the set of y coordinates, so you're going to look at the y-axis and look at the lowest point on the graph right here. So the lowest y coordinate I see is -4, and that point is in the graph, so -4 is a bracket. You're going to include the y coordinate -4 in the range, and it's defined. There's y coordinates, and it's going to keep going all the way up, up, up. So the range is from bracket -4 to infinity with a parentheses because you can't contain infinity. Alright, so the next ones, usually if this were class, I would say try it. You may want to pause the video and try it and see if you get the domain and range right. But I'm just going to keep on going. So the domain here, you have 0, and that's -2, -2. So this is -1, and that's -2, and this is 1, and this is 2. Pay attention to what we're counting by. Sometimes they might not be counting by 1, so you have to pay attention. Alright, so the domain is the set of x coordinates, so we're going to look at the x-axis, and the number to the farthest to the left is this order pair here, -2, -2. So -2 is the smallest x coordinate that we would write down. Now we have to decide, are we going to put a bracket here or a parentheses? Well, it's a hole, so it's what we call an open boundary. We need to put the -2 down, but it has to be a parentheses. And then all these x coordinates are defined, 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 defined until we get to 2. And 2 is a point that 2 is a point included in the graph, so we're going to have a bracket. So that was your domain. And your range, that's the set of y coordinates. The lowest y coordinate is -2, and this time there is no other point, so you would put parentheses on -2, and all the y coordinates are defined, and the highest y coordinate that we have here is 4.25. And so since that point is included in the graph, that would be a bracket. Alright, the next one, this is an absolute value function. And again, we just assume it goes on forever and ever. This is an absolute value function. You will need to know the certain types of functions, what they look like. Here's one. That's the absolute value. They always look like V's, either opening up or opening down. And the domain is the set of x coordinates, and it's going up, up, up forever, but it's also going to the left forever. So the domain is -infinity, and it's going to the right forever. So the domain is -infinity to infinity. The range, we're going to go and look at the y-axis and look at the smallest y coordinate. The lowest it gets here is this y coordinate of 0, and that is a point. So we would have a bracket, and then it's going to go, all these y coordinates are going to be defined forever and ever, so it's going to go up to infinity. So that's the range. Okay, let's see what else we got here. Next thing, definition of a function and the vertical line test. So a function is a relation. The word relation just means what we were just talking about. Every function, there's a relationship between our inputs and our outputs. In function notation, something that people aren't comfortable with all the time, this is a function notation for an ordered pair. If I know x and I put x into the function, it'll spit out a number. So a function is a relation, an input and an output, between two sets, assigning each element in the first set exactly one element in the second set. So the elements in the first set, those are the inputs, and the elements in the second set, those are the outputs. And it's fancy definition, but it's really easy to remember. Each element of inputs can only belong to one element in the output. That means, in other words, the x's, the x coordinates, must always be different if you want it to be a function. Sorry about that blurriness. Okay, so that means that if I had the point 2, 3 and the point 2, 4, and this was a relation, that's not a function. No, because that x coordinate 2 is paired with both 3 and 4, so that's not a function. The x's must be different. Okay, so again, the first set is called the domain, or the set of inputs, independent variables, or x coordinates. So just kind of review. And the second set is the range, and that's the set of outputs, or y coordinates, or dependent variables. Okay, so now the graph of a function is a curve in the xy plane. So we've been looking at functions, but the question arises, which curves in the xy plane are graphs of functions? The easiest thing to do is to use the vertical line test. It's a way of testing this idea here. So for example, if I'm looking at this function and I want to know, are all the x's different? Then all I have to do is use something called the vertical line test, where what you do is you just pass a vertical line through the life of the function, and as long as that vertical line isn't being intersected but once every time you pass through that function, it's a function. However, over here, here's another graph. This is a relation. It's made up of ordered pairs, but is it a function? Well, if we apply the vertical line test, we see that this graph intersects this vertical line in two places. We will call this AB, or we can make it maybe 2, 4, and maybe this point we'll call 2, -4. And see how this 2 is paired with a +4 and a -4? That means it's not a function. So it fails the vertical line test when it crosses it. The function, the relation crosses the vertical line in more than one place. So that's a really easy way to test whether something is a function or not, the vertical line test. Okay, again, at this point we would stop and practice, so you can pause the video and tell me which one of these are functions and which ones are not functions. But I'm going to keep going. So this function fails the vertical line test, so that's not a function. This function looks like a cubic function, a degree 3 function, and it's passing the vertical line test. So that's a function. This is our absolute value function, and it's passing the vertical line test. So it's a function. And this is just a relation, and it fails the vertical line test because it's intersecting a vertical line in more than one place, so that is not a function. Okay, so next we move to reading a graph. So here's our graph, and again, convention, let's just make sure we know that those are points, and this is a point, and this is a point, but that's a hole right there. That is not a point. Okay, and it says use the graph of f to find the following. So now we really practice on this function notation. So f of 1 means when x equals 1, what is y? That's what this function notation means. When our input is 1, what is the value of f when x is 1? So I'm going to go over to the graph, and when x is 1, I see this point here, and when x is 1, y is -1. So f of 1 is -1. Okay, over here I have f of -4. That means when x is -4, what is y? What's my output? So I'm going to go over here on the graph. That's -1, that's -2, that's -3, and that's -4. And it looks like when x is -4, y is 0. So f of -4 is 0. Okay, and now we're going to go the other way. So these are what I call output input questions, and they're always a little harder. This is saying when I know that y is -3, when my output is -3, what is x? Now the reason they're harder is because you can have more than one answer here. Here you can only have one answer because of the definition of a function. Here you might have more than one. So the coolest way to do this is if I give you the output, f of x equals -3. Another way of thinking of it is y equals -3. And this you can graph. Y equals -3 is going to always look like a horizontal line through -3. Can't spell horizontal. So if I know that f of x equals -3, what I'm going to do is draw a line 1, 2, -3 on my graph, and I'm going to make sure I pick up all the x coordinates that are crossing through y equals -3. Now in this case it's only happening one time, about right there. And you have to approximate, and that's okay. I'm going to say x is approximately negative, and somewhere between -4 and -5, a little bit more than halfway, so maybe -4.7. And that's it. However, look at this one. Find x such that f of x equals 0. Same idea. This is a y, so if I put a graph y equals 0, and I'll use different color pen. If I go through this graph y equals 0 like this, see, this time you can see that there's more than one intersection. This point right here, we already said was negative 4, 0. This point right here is 0, 0. And this point right here is 2, 0, but is it a point? No, it's a hole. Okay, so this is, the answer would be, all right, what is x such that f of x equals 0? Well, when x is negative 4, y equals 0. And when x is 0, y equals 0. But when x is 2, there's a hole there. That's not really a point. So we aren't going to say y equals 0. That's it. Don't say x equals 2 as an answer, because f of x really isn't equal to 0 right there. There's a hole there. Alright, so you would try this one. You could pause the video. Alright, so f of 1 means when x is 1, what is y? So right here, when x is 1, y is 2. And then we have this trick question. When x is negative 1, what's f of negative 1? So this graph starts here at 0, 0. And so when x is negative 1, there is no y coordinate. So it does not exist. And the reason is because negative 1 is not in the domain of this function. The domain of this function starts at 0 and goes to infinity. So negative 1 wasn't even in the domain, therefore the y coordinate does not exist. Alright, so C is an output-input question. I'm telling you that when y is 4, but I need you to tell me what x's make that happen. So I like to do this by drawing a horizontal line. Here's where y equals 4, and y equals 4 when x is 4, and that's the only answer. And then here, find x such that f of x equals negative 1. Well, down here's where y equals negative 1 is. And again, same thing. There is no x coordinate that's going to make y equal negative 1. And if you finish this out, the range is the lowest y coordinate is 0 to infinity. So negative 1 isn't in that range. So those two questions are tricky, interesting. They do not exist. Okay, so the next definition, what is a one-to-one function and what's the horizontal line test? Okay, so a function is one-to-one on a domain D if each value of f of x corresponds to exactly one value of x in D. More formally, f of x is one-to-one on the domain if the y coordinates don't equal each other whenever the x coordinates don't equal each other. Okay, and as usual, it's complicated. All it's saying is that the y coordinates have to be different. Okay, so a function is one-to-one. Well, if it's a function, remember the x's are different. And if it's one-to-one, then the y's are also different. So look at this one. This one, you may want to know, this is a radical function. Radical functions look like this. They start at one spot and then they just go to the right or the left. And it's one-to-one. There are no repeating values. Like if it looked like this, it wouldn't be a function, right? But it doesn't. It's only kind of half a branch. So this is a one-to-one function. Alright, the horizontal line test is what you use to tell if something is one-to-one or not. Okay, so if a horizontal line intersects the graph of f at more than one point, then there are numbers x1 does not equal x2 such that f of x1 equals f of x2. That means that if these are equal to each other, then these can't equal each other. So basically it's just saying use the horizontal line test. So if I use this horizontal line test, I have this point here which says, really hard to see, 0.4691, and this point here 5,1, and this point here 8.5311. And see how the y's are not different? They have a bunch of partners, 0.4695, 8, so this is not a one-to-one function. It is a function. It's passing the vertical line test. So it passes the vertical line test, so it's a function. It fails the horizontal line test, so it's not a one-to-one function. And it's kind of getting ahead, but you're going to need to know whether things are one-to-one or not when we talk about inverses, because only one-to-one functions have inverses. So right now we're just learning the horizontal line test, one-to-one functions, the y's have to be different. Vertical line test, that's the test for whether something's a function, the x's have to be different, but we'll have more context later. Alright, you can pause the video and figure out whether these are one-to-one functions or not. Okay, so this one passes the vertical line test, so it's a function. It also passes the horizontal line test, so this is a one-to-one function. This one is really hard to see, but there's a hole there, which is really important, and this is a colored dot. So this, you might think, is failing the vertical line test, but no, it's not really. It's passing it, because there's only one point crossing this vertical line. This is not a point. So it's a function. Now, is it one-to-one? Well, if you draw a horizontal line like that, you can see that this function is crossing the horizontal line in two places. So this one is not one-to-one. This is our absolute value function, passes the vertical line test, but it fails the horizontal line test. So this absolute value function is not a one-to-one function. It is a function, but it's not one-to-one. Again, this is what we call a cubic function, and it's a function. It's passing the vertical line test, but it is failing the horizontal line test. So this is not one-to-one.